All right, in this tutorial, we're going to go over the GCF of monomials, and the GCF stands for greatest common factor. Now, way back in the very first unit, we talked about finding common factors of numbers, and we're essentially doing the same thing here, but this is also going to include variables and possibly variables with exponents. So, just as a reminder, the greatest common factor is the greatest factor that divides into multiple terms. And when you are looking for this GCF, you're going to list all of the prime factors and determine what is all in common between them. Now, if you look back into the very first unit, I had a video that went over factor trees. You can still use these to find your common factors between your two or your multiple monomials. But as you get more familiar with the numbers and the factors, you may not necessarily need to always be finding the factor trees. So in this first example, it's pretty easy with the numbers, but we're just going to kind of incorporate how to use the variables when finding your greatest common factor. So your first one, you could break this down. 5 is a prime number, and then there are two different x's that are being multiplied together. So you can write those individually out as 5 times x times x. Now, 15 is not a prime number. We can actually find factors of 15, and those two numbers are 3 and 5, but those are both prime. So we're going to write 3 times 5, and then there's only one x. Now, looking between the first row of all of your common terms with the second row, you can determine that there is a 5 and there is one x that is in common between both of those. Now, the first term has two x's, but you can't circle this x with an already circled x beneath. If there was an uncircled one, then you could say that those were in common as well. But the only thing in common between the 5x squared and 15x are the factors of 5x. That is your GCF, your greatest common factor. Now, moving into the next example, a little bit more challenging as far as the numbers and the variables. 24 is not prime. We're going to go ahead and use our factor tree. We've got 3 and 8. 3 is prime. Factors of 8 are 2 and 4. 2 is prime, and then factors of 4 are 2 and 2. And then there are 5 x's. So for 24, x to the 5th, we have 2, 2, 2, 3, and then 5 x's. Now in 34, our common factors are 2 and 17. Both of those are prime, so we're going to go ahead and stop right there. 2 times 17. And then there are 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so now looking at what is in common between your 24x to the 5th and 34x to the 9th. Well, we've got a 2 here, and then we have a bunch of x's that are in common. I'm going to circle until I can't circle any x's in both rows. That takes care of all of them, so there are 5 in common between the top and the bottom. Notice that your lowest degree symbol, your lowest exponent, is what is the number that your common x's are. You don't have 9 x's in the first one, so you can't say that there are 9 in common. But if you have a group of 9 in the second one, there is a group of 5 within that group of 9, so that's how many in common that you can take out from the two terms for your greatest common factor. So there are 2x to the power of 5 as your GCF.